What separates meaningful research from guesswork? Why do some studies influence policy, science, or psychology while others just completely fade away? Now, the answer lies in the quality of the research itself. In this lesson, we're going to look at the key qualities that define good research, which is qualities that help ensure that the research is trustworthy, it's repeatable, and valuable in real-world decision making. Now, the first point is good research is systematic. This means that it follows a clear and logical structure. Now, it adheres to a step-by-step process that includes identifying a problem, forming a hypothesis, collecting data, analyzing it, and finally drawing conclusions. So this sequence must be very well planned and documented to reduce errors. Being systematic doesn't mean research can't be creative. It actually means that creativity is applied within a disciplined structure and not the guesswork or random trial and error methods. Now, the second point is empirical. Good research is based on empirical evidence and not assumptions or beliefs. Now, this means that conclusions are drawn from real-life data, observations, and measurable facts. Empirical research uses tools such as interviews and experiments or surveys to gather information from actual experiences. As a result, the outcomes of the study are grounded in reality and they can be applied or tested further if needed. Now, the third point is it should be valid and verifiable. High-quality research is both valid and verifiable. Now, validity ensures that the research truly measures what it claims to be measuring, and verifiability means that the findings can be independently confirmed by repeating the study using the same methods. Another term for this is reliability. Now, to achieve this, researchers can use reliable instruments and apply statistical methods to describe results accurately. The fourth point is logical. So good research must be logical, it must be guided by reason and structured thinking. It uses both inductive reasoning, which is where inductive reasoning actually means that you're drawing a general conclusion from very specific cases. So let's say you have a few cases that you've noticed in cancer, and from these few cases you are drawing a general conclusion that all cancer patients will, have nausea at a certain point, or will show a decreased ability to fight off diseases. So that might be your general conclusion based on the specific cases that you've looked at. So that is called inductive reasoning, where you've taken a few cases and you're using the information that you gathered from there to generalize on a larger population. Deductive reasoning is where you're applying a general theory and then bringing it to specific cases. So you're saying that because these people are part of cancer patients, in general, cancer patients all experience this. Therefore, these people in these specific cases will also experience this. So this is how you go from inductive and deductive reasoning, how the difference occurs. Now, logical reasoning ensures that the research process is coherent, it's purposeful, and capable of leading to practical or theoretical insights. So without logic, research actually becomes arbitrary and it lacks any kind of scientific rigor. Anyone can just come up and say, this is how it is, and this is a principle, and this is how things work. But you need actual research and actual facts that substantiate what you're saying. Only then can you say that there is scientific rigor involved in there. Now, the fifth point is theory generating. A major aim of research is to develop theories or generate general principles. So good research should allow the researcher to make generalized predictions based on the findings from a sample. So if you do a little experiment and you find something based on the experiment you did in a small sample of maybe 10 people, you should be able to predict that in a larger mass of people under the similar conditions, this particular phenomenon will occur again. So that's why we're doing all these researches, to be able to specifically say that what you see in the small group is also going to be seen in the large group. Inductive. So it moves beyond the specific study and contributes to wider understanding of related concepts or populations. Now, this helps in predicting the behavior, identifying patterns, and solving future problems. The sixth point is replicable. Research must be replicable. So we just talked about that before in one of the points, but we're going to explain it again. Research must be replicable. This means that other researchers should be able to follow the same procedure and obtain similar results. Replicability ensures that there is transparency, there's accountability, and there's scientific validity. It also allows the research findings to be built upon, expanded, or challenged, which creates a dynamic and evolving field of knowledge. So, in summary, good research is more than just collecting information. It is a disciplined, evidence-based, and logical process. It should produce valid results, it should have the capacity to develop theories, and it should be structured in such a way that others can test and replicate it. So whether you're studying human behavior or you're designing a psychological experiment, adhering to these qualities is essential for producing credible and impactful research.